You open your laptop, scan the to-do list for Monday and Tuesday that you created on Friday, and you feel nothing. Couldn't care less. The word most of us reach for is burnout. Burnout is real, but it's not what I want to talk about today. About 70% of women notice emotional and cognitive changes during perimenopause. A large 2024 review in the Journal of Affective Disorders reported a 40% higher risk of depression in perimenopausal versus premenopausal women. But a lot of what gets called burnout at this point isn't quite that. It's actually a disruption in the brain's dopamine system, or as many women refer to it scientifically, we don't give an F word about it. And those are different problems, which means they need different solutions. I'm Dr. Yura Lašas, a neuroscientist with 15 years of experience in clinical research. I specialize in translating complex brain science into clear explanations for professional women who are navigating perimenopause and want to understand what's really happening. I'm someone who's highly motivated. I love my job, and I genuinely get excited to start my day in a quiet house, coffee in hand, with kids at school. But I do have those days when I open my laptop in my home office and just want to give up. I can't summon any interest. I'm not tired or anxious. I simply don't give a rat's ass about the meetings lined up or documents needing review. Estrogen, dopamine, and a few brain systems are talking to each other. And when estrogen starts fluctuating the way it does in perimenopause, that conversation gets disrupted. The result is what a lot of us feel but can't quite name. We're not sad, not exhausted, just oddly indifferent. We simply don't care. To understand why, we have to start with the dopamine. Because most of what you've heard about it is wrong. Dopamine is not pleasure chemical, but that's probably what you've heard many times before. Ken Berridge and Terry Robinson spent decades teasing apart two things our brains treat as totally different: wanting something and actually liking it once you have it. Their work, starting with animal studies and later lining up with what we see in humans, showed that dopamine isn't about pleasure at all. It's what creates the pull towards the goal. That feeling that the effort will be worth it. The good feeling you get when you finally arrive. That's handled by a different system. You can lose the wanting while the liking stays just fine. Once you're doing something, you still enjoy it, but nothing pulls you towards getting started. A project you cared deeply about a week ago, now you don't really care about. That's not a sudden personality change that happens with your 47th birthday. It's your brain's wanting signal getting weaker. Dopamine is what helps you get started. Stick with the effort and stay motivated by future reward. It also creates something neuroscientists call reward prediction errors. Basically, is the signal your brain sends when something turns out better or worse than you expected. That signal is how your brain learns what's worth doing again. When it weakens, everything starts to feel equally unimportant. Nothing stands out. The problem during perimenopause isn't primarily that you are not making enough dopamine. It's how long that dopamine stays active around neurons in the synapse. It's a connection between neurons after it's released. Remember, it's a message between neurons. And estrogen is what helps control that. By now, we all know that estrogen is not just a reproductive hormone. Not everything is about having babies. It's a neuroactive steroid with receptors expressed throughout the brain regions responsible for reward and motivation: nucleus accumbens, prefrontal cortex, hippocampus, and basal ganglia. Estrogen acts directly in the brain. Please note that most of our knowledge about the estrogen receptors and where they're located comes from animal studies. We don't have that level of detail in living human brains. However, the basics are the same across species. There are 3 ways or mechanisms how estrogen affects dopamine. Pause here and subscribe if this is the kind of content you've been looking for. I publish every week. Each video breaks down one specific aspect of perimenopause brain science with cited research you can check yourself. Neurons are talking to each other. One neuron releases dopamine as this kind of message for another to accept it. It needs to bind to a receptor on that neuron. But it's not so simple or straightforward. There are two janitors that sweep in to clean the spill, which is dopamine. Those janitors are enzymes, and estrogen inhibits them both, which means that dopamine hang around the neurons for a little longer and the message gets across better. However, when there is less estrogen during perimenopause, the enzyme janitors are quicker to clean up the dopamine, which translates into less motivation. This first mechanism has been confirmed both in animal and human research. The second mechanism of how estrogen affects dopamine comes from rat studies. It hasn't been directly shown in humans yet. I'm including it because the experiments are really good. They're solid. The biology makes sense, and it lines up with what we're seeing in human brain scans. A study published in the prestigious Nature Neuroscience in late 2025 looked at female rats and found that higher estrogen levels were linked to fewer dopamine transporters in a key reward area of the brain. Dopamine transporters are like vacuum machines sitting on the surface of those neurons. Their job is to suck dopamine back up after it has been delivered its message. So when estrogen is high, there are fewer vacuum machines and dopamine sticks around longer after it's released. As a result, reward signals are stronger. Rats learn from rewards faster and were more motivated to go after their goals, whatever the rat goals are. Probably food. When researchers dialed down the estrogen signaling in the midbrain, motivation dropped, but decision-making didn't change. The effect is very specific. It hits the wanting system, not everything else. Again, it's rats. But human functional MRI brain imaging data points to the same direction. Let's look at the third mechanism, how estrogen affects dopamine. A 2025 review in Brain Sciences found that activating a specific estrogen receptor alpha in the basal ganglia, which is responsible for reward-based learning and motivation, is linked to stronger reward-seeking behavior and better cognitive performance. Most of the studies behind that finding come from animal research again. However, we see the pattern in menopausal women: lower motivation and more anhedonia, a fancy word for not being able to experience pleasure or interest in activities. What we don't have is direct proof of mechanism in humans, but it's worth noting. The three mechanisms help explain why there are days or even long periods when we simply do not care. Dopamine is the main story today, but perimenopause doesn't politely disrupt just one neurochemical system. Wouldn't that be nice? It hits 4 simultaneously, which is in part why perimenopause can feel destabilizing even when on paper your life looks just fine. Let's look at estrogen, including progesterone, relationship to the rest briefly. If there's interest to learn more about all brain system, drop a comment and I'll create more videos. To remind ourselves, dopamine governs motivation, reward, and drive. Estrogen allows dopamine to stay active longer, and the decrease of estrogen can lead, and often does, to a loss of drive and motivation and anhedonia. Serotonin governs mood stability. Estrogen actually helps your brain make more serotonin, use it more efficiently, and respond to it better. So when estrogen drops, that whole system can get disrupted, which is why mood swings, depression, and that low-grade irritability are so common in perimenopause. We also have to talk about GABA and progesterone, which is doing the heavy lifting here. GABA is your brain's main calm-down neurotransmitter, another message between those neurons. It's essentially the brakes in the brain. Progesterone is converted into a compound called allopregnanolone in the brain, which directly activates GABA receptors on neurons and keeps you feeling calm. When progesterone drops, those brakes are not as good. That can show up as anxiety, irritability, trouble sleeping. Finally, the famous HPA axis, hypothalamic pituitary adrenal axis, helps your brain manage stress. It controls your cortisol response. There is so much false information about cortisol and what it does that I'll need to make another video just dedicated to it. Back to estrogen and HPA. Estrogen helps keep that system regulated so you respond to stress appropriately, and estrogen also helps shut down the stress system off when it should. When estrogen declines, that regulation isn't as effective and you might start overreacting. Things that would normally roll off your back suddenly feel completely overwhelming, like your coworker slurping their water or your partner loudly breathing. So far, we talked about mechanisms discovered in animal research and some of it confirmed in humans. 3 papers came out in 2024 and 25, all from the same research group at University of North Carolina at Chapel Hill. And together, they're pretty striking. They use functional MRI brain imaging to directly observe what estrogen applied to the skin does in the brain. These studies looked specifically at women who were diagnosed with major clinical depression that began during perimenopause, not perimenopausal women in general. So how large the estrogen effects were may not apply the same way to women without depression. That being said, the mechanisms behind it fits neatly with the animal research has been predicting all along. The researchers gave women transdermal estrogen for 3 weeks and then scanned their brains. What they found is that the loss of drive, the inability to feel rewarded by things they cared about, has a measurable neural signature. The brain is literally working harder than it should have trying to generate motivation. The reward system isn't working well in the brain. 3 weeks of estrogen helped brain not to compensate as much. The brain connections responsible for reward became stronger, and the women with the most severe anhedonia, which is not being able to experience pleasure or interest in activities, showed the biggest improvements. They even noticed the hippocampus got a little bigger in women that responded well. What a cool way to see a neurobiological response in perimenopausal women on a scanner. Before we get to the practical what do I do now part, we have to talk about BDNF. BDNF is a brain-derived neurotrophic factor that does many things. It promotes neuronal survival, growth, and the strengthening and formation of synapses, the connection between neurons. I like to call it brain growth juice. BDNF might help explain why cognitive fog and motivation loss tend to arrive together and why the same interventions help both. Estrogen helps your brain make more BDNF. When estrogen drops, your brain makes less of the BDNF, the growth juice. In observational studies, postmenopausal women tend to have lower levels of BDNF than premenopausal women. And those lower levels are linked to more depressive symptoms. Estrogen turns out to be a key contributor in many brain areas that affect how well we're motivated and how much we care about our work or daily activities. So how do you get that mojo back? That I love getting stuff done momentum that used to be automatic? First thing that you can do is very simple, and most of us will not love it. It's exercise. Aerobic exercise increases BDNF in the brain. Just 5 intense minutes is enough to change the brain chemistry. You're not making motivation happen by moving. You're priming your brain with what it needs so motivation can show up on its own, which matters because you don't have to feel motivated first. I'm a big believer in exercise snacks. These are intense 5 to 10 minute exercises sprinkled throughout the day. For example, I would do 50 jumping jacks or 25 burpees, some push-ups, some squats. It's not the pleasant stuff. By the way, dopamine is made from tyrosine, an amino acid in protein. The second thing you can do to help your mojo is to eat enough protein so you have the building blocks for your motivational neurotransmitter. Nothing magic or special. Just be mindful to get about 30 to 40 grams of protein with each meal. When the reward prediction system is not working well, the normal wins like finishing a report, going for a walk, or having a nice conversation do not help you get the juice flowing. You need to use a few cognitive tricks to engineer the environment to force yourself to care. Don't set long, abstract goals. For example, get my career back on track. What you need is a concrete goal that has a very clear completed outcome. For example, finish the first section of this deck. Book that doctor's appointment. This teaches your nervous system to reinforce the reward system. You put in effort and it paid off. The second thing to do is think about is when everything is predictable, nothing really registers. But small bits of new stuff like a new place, a new breakfast, a new tiny experiment can give your brain something to react to. And that little spark can go a long way when things feel flat. And finally, it will help if you deliberately notice what went well. When motivation is low, your brain doesn't always register the wins on its own. So you have to point them out. Take a moment to say, hey, that actually went well. That small pause helps the brain remember this was worth doing. The brain scans I talked about earlier show that for women whose depression started during perimenopause, estrogen patches helped to regain the reward system in just a few weeks. Whether hormone therapy is right for you depends on your history, risks, and symptoms. And that's a conversation to have with your doc, not a YouTube video. I'm bringing it up because a lot of women are never even told it's an option. It is. It's just not magic. Just one tool. And like any tool, it helps in some situations and not in others. To summarize, estrogen affects how long dopamine sticks around and how motivated your brain feels to go after what matters to you. We're still filling in some of the details in human studies, but the overall picture is pretty clear. So if your drive doesn't feel the same, try not to turn that into your self-criticism. There's real biology behind it. And it's a lot more useful to understand that than to beat yourself up. You're not imagining what you're experiencing. It's real neurobiology. Press like to help other women find this explanation. Subscribe so you're here for the next science breakdown. And share this with someone who's been told it's all in her head. And I will see you next week.